Previously, we studied the photoelectric effect, which gave us evidence that when light interacts with a metal surface, free electrons are emitted, and thus concluded that light is made up of packets of energy called quanta, and that E is equal to h nu. Einstein associated light quanta with momentum, that is h nu by c, thus strongly supporting the particle nature of light. These particles were later named photons. Thus, the wave-particle dual nature of light was concluded. We summarize the property of these photon particles in the following manner. When light or radiation interacts with matter, light behaves as if it is made up of particles called photons. Each photon has energy E is equal to h nu and momentum, that is P equal to h nu divided by c. All photons of a particular frequency f or wavelength lambda have the same energy E and the same momentum irrespective of the intensity of light. So energy E is equal to h nu is equal to hc by lambda, and momentum P is equal to h nu by c or h divided by lambda. The intensity of radiation does not depend on the energy of the photon, but with an increase in intensity, the number of photons crossing a given area increases. Photons are electrically neutral and are not deflected by any electrical or magnetic field, and the total energy momentum of the photon is conserved during any interaction of a photon with an electron. The number of photons may or may not be conserved during a photon-matter interaction or a photon-electron collision, which means that photons may be created or destroyed. Let's summarize these points.
Manorama Horizon. Learning made simple.